Hey everyone, welcome back to the Naughty Samurai channel. I hope you're all doing well. Today we are diving into something really useful in data preprocessing, which is the functional transformer. So here is the problem. Sometimes even after scaling or normalization techniques, the pattern of your data still remains highly skewed or non-normal. This means the usual methods like min-max scaling or standardization don't always give the expected results. To fix this, we can apply mathematical transformations like logarithms, square roots, or other custom functions to make the data more normal-like. This is where the function transformer comes in handy. With a function transformer, you can apply power functions, log functions, or any custom functions of your choice. What they do is they squish your values down so they are easier to fit the models. In such cases, you can still use a function transformer to adjust the scale and pattern of your data without removing the outliers. This allows your model to learn effectively even with some extreme values present. For those who don't know what outliers are, I have covered this topic in one of the previous videos of this series, so I suggest you to go check that video out if you want to really understand the concept in depth. But I would still explain what outliers are in brief here. So outliers are values that differ significantly from the rest of the data. Like suppose if most of your data is between 1 and 10 and there is a value which is 100, that 100 would be considered as an outlier. Outliers can distort your model's understanding and predictions if not handled properly. Usually you might remove outliers, but sometimes these values are too important to ignore. In such cases, you can still use a function transformer to adjust the scale and patterns of your data without removing the outliers. This allows your model to learn effectively even with extreme values present. In short, the function transformer gives us flexibility to reshape our data, normalize distributions, and make patterns easier for models to understand significantly when standard scaling techniques don't work. If you guys got a clear understanding of the when and whys, let's cover the applied part now. First, our usual to-do core. We will install the KaggleHub library and then we will import all the libraries that we will need. Pandas, OS, Seaborn, and Matplotlib are some of them. Then we will take our dataset. We will download it from KaggleHub. I would be attaching the link to this in the description box below, so do check that out. So this is the dataset that we are using here. Before we do anything, let's target a column that we will apply the function transformer on. So here I would be choosing any of the applicant income column or the co-applicant income column, because if any of you have watched my previous videos, you would know that these two columns are the columns that I have worked with always. So let's target co-applicant income column here. So before we apply the function transformer, let's make a distribution plot diagram for this column and how it looks, so we can actually analyze what changes were made after we applied the function transformer. So we will write sns.data_displot, and within this will be the name of the column, which is co-applicant income. Now we will just write plt.show and we will run it. So this is how the graph looks like now before applying the function transformer. Here you can see that most of the values range between 0 and 10,000, and some values are also far-fetched up until 20, 30 and 40,000. So the values that are away from the median values are normally considered outliers. So we can actually deal with these outliers after we apply the function transformer. As we are done seeing the before graph, now let's apply the function transformer. So first we will import the function transformer library, the function transformer class. We will import it from sklearn.preprocessing. Next, we will need the numpy library, so we will import numpy as np. Now, what we want to do is we want to create an object of the class function transformer. So let's name it ft, and within the parenthesis, we will pass the name of the function. The first function that we want to apply is the logarithmic function. So let's write function is equals to np, we will call the numpy library, and from that we will call the log function. So how this function works is that it actually takes on the value of x. So we can write it as log 1p x here, and then it actually stands out as log 1 plus x. So what it will do is it will take on all the values of rows. For example, you get, so here all the individual values of the rows for this co-applicant income column are given. So we take on all these values individually and we replace it with x, and then we sum up 1 with it, and after that the result that we get after applying the logarithmic function on top of it is the result that we really want. And all those values of the co-applicant income column are now replaced with the value that we get after applying these functions on all of the individual values. So this is how it usually works. There are many other logarithmic functions as well. You can explore it if you want, but this is how it usually works. You just have to write the function name within this parenthesis, and you're good to go. So let's run this cell now. Now we want our function to fit on our data, so we will write ft.fit. Here we will give 2 parentheses and not 1. Please keep this noted. Now we will write the name of our column, which is co-applicant income column. So co-applicant income column goes in here, and we can run this now. So this works. Now the only thing we are left with is applying the transform method. You always apply the transform method after you're done fitting the data. So what this fit function does is that it actually understands and kind of scans the data and learns from it. And finally, when you apply the transform method, it will shift or replace all the values that we get after applying the logarithmic function. So let's do that. ft.transform, and within it we will pass the same thing again, which is the name of the column with dual parenthesis, as you know. So co-applicant income column. Now let's run it as well. So these are the values that we are getting, and all these values are the values that we get after applying the logarithmic function, and these values will replace all the previous values present in this column, which is the co-applicant income column. In order that we can visualize the before and after graph in a better manner, why not create a new cell, create a new column out of this data. So now let's create a new cell, and the name of our new column can be co-applicant income column. Co-applicant income new, and this will be a new column that we will create, and it will have all the values of this transform data. So let's paste it here and run this. Now let's call our data set again. So now you can see at the very end of it, there should be a new column which we can find here, and all those previous values have been now replaced, and these are the values that we get after applying the logarithmic function. Keep it noted that there are many different sorts of logarithmic functions. So whatever logarithmic function you apply, these values will differ according to the function you apply. We will get some other value if we apply some other logarithmic function. Here we applied log 1 plus x. So the values that we got here are this. But let's see what happens when we apply a different sort of logarithmic function. There are many. You can choose any based on the model you're working with, or the type of result that you want, or what your ambition is. So let's change the function from log 1p to now log base of 10. So let's run this. Fit our transformer on top of our data, and finally transform it. Alright, so these are our new values. You can see there are many negative infinite values present here as well. So I think the function that worked well out of this two is the previous one, which is log 1 plus x, or log 1p. Anyways, let's run this cell and finally call this cell again, and you can see the values have now changed. These are new variations of values that we get after applying log base of 10. But I think the function that we applied previously worked better on this data set. So let's get back to the previous one. Okay, so we are now back to the results that we got after applying the previous function. So now let's plot a diagram where we showcase the before versus after distribution of our graph for this column, and see how the values of outliers have changed. So for drawing the distribution graph, I am just pasting a code that I've written. I feel too lazy to write it down, but I suggest you go through it line by line and write it down yourself so you can understand it better. So let me run it. And here is our graph that compares before and after applying the function transformer. So before, we can see that most of those values were stretched from 0 up until 40,000, and there are many outliers present because most of the values are within the range of 0 and 10,000, and some values that are away from the median, which lies between 0 and 10,000, are considered as outliers. But after applying the function transformer, you can see all those values that were in the range of thousands are now between minus 2.5 and 12.5. So they are very closely packed values, and these values are actually now close to the median value, and you can feed these values and your machine learning model will react and work with this data in a better manner than it would work previously before applying the function transformer. Now what we will do is we will apply some other function apart from the logarithmic ones and see how the values react to that. But before that, we will have to create a new version of the previous data set, because if we use the exact same data set with the same variable, then the values that we will get intertwingled, and we don't want that. We want accurate results. So let's create a new data set with a new variable data2, and let's run it. So this is our new data set. Now what we want to do is we want to apply our function transformer again. We won't have to import the class again because we already did it previously. What we need to do is we will have to call the object from the class. ft1 is a new object, and within it we will pass the name of our function. The function that I want to apply is xcube. If you want, you can apply some other functions as well. There are plenty. If you want, you can apply x square or x to the power 4 or x, whatever you want. But I would be applying x cube. So x cube goes here, and the next step would be for our transformer to fit on our data set so that it can learn. So we will write ft1.fit, and within it we will pass the name of our column, and let's copy it. Let's copy it again, paste it, and replace the fit with transform. Let's run it. Okay, so you can see these are the values that we get after applying the xcube function. All those values that were present before have now been replaced with the values that we get after applying the function. Now let's create a new column for this particular, new values. So let's copy it. Okay, no, I don't have to copy it actually. I will write data2. The name of our new column can be new co-applicant income. Okay, so this is our new column. Let's run it. And let me call the dataset again. And we will get our new column at the very end. So this is our new column, and these are the new values that we got. Okay, now the thing we will do is we will plot the distribution plot diagram and see the difference. Okay, let's paste it here. Okay, let's paste it here. Change the names to data2. And let's run it. Okay, we have to change the name of the column. We named it to new co-applicant income column. Okay, let's run it. So here's our graph. Okay, surprisingly, you can see this function actually performs better, and you can see all the values are now within a specific range of 0, and it did not even exceed 1. So you can see the clear distinction. There were many outliers present, as the values were far-fetched up to 40,000 previously, but even in the new graph, there are some outliers present, but you can see those are not that far-fetched. They are in the values of tens and not thousands. So this is how the function transformer works. You can keep on testing by applying different functions and work with what works best for your model. I hope you guys understood the concept, and if you did, please do not forget to like the video, drop a comment, and subscribe to my channel. I will see you guys in the next video. Until then, keep your mind sharp, your code clean, and stay sane. The Naughty Samurai signing off.